Hello and welcome to my webinar. My name is Van Ruppert and I will explain you how you can start with DevSecOps. We are focusing on the term security. I want to explore a little bit what happened in the past, what we could learn from this one, and how you can start inside your organization with DevSecOps. What are the low-hanging fruits? What are the first tools you can use? So if you're interested in this, stay tuned. Okay, before we are going into the details how you can start with this one, I want to highlight something that happened in the past, and maybe the most of you heard about it. It's the SolarWinds hack. So what happened here and what we could learn for ourselves out of this huge incident, I want to explain in a few seconds. Okay, what's SolarWinds? SolarWinds is a company from US, and they have a lot of customers. So we are talking about a few 100,000 customers, and they are creating a product called Orion platform. And this Orion platform is a software that is managing network infrastructure inside a company or whatever it's using this platform. The main thing here is it is managing infrastructure. So in this, for this management, you need the rights as an administrator. So you need a lot of rights, and you are in a very critical infrastructure part of an organization, so the networking itself. So on this company with, I don't know, 300,000 customers, they had a challenge because they got compromised. And well, for this, I have to talk a little bit about FireEye and how this happened. To have a complete picture what happened here, we need a few information about the company FireEye. FireEye is a company that's specialized on identifying attacks against IT infrastructure. And normally a customer is going to FireEye and then they are requesting an attack against their own infrastructure to get a report and advise how to make this more secure. So then, end of 2020, December, the company FireEye detected an attack against their own infrastructure and found out that they were compromised. So what happened here is that the group that attacked the FireEye infrastructure was able to break in, and they got the toolset from FireEye. So the toolset from FireEye to test other networks was stolen. A little bit sometime after this, there were a lot of compromised systems, US government, pharmaceutical industries, whatever. So a huge, broad attack was going on. And it took some time to combine these attacks with this hack against FireEye. What happened? The group that attacked FireEye was able to steal this software, use this software to attack or to analyze the company's SolarWinds. And their product, Orion, this networking management solution, that was built inside the CI system of the SolarWinds company, or the company called SolarWinds. And now the attack was not against the final target, what they want to have. No, they attacked the supply chain. So they manipulated the CI environment from this company so that every time they're building a release or an update or whatever, the compromised binary that was provided by this hacker group was just merged into this final release. With this, SolarWinds was creating fingerprints, was distributing fingerprints of their fresh generated binaries, and the other side that was consuming this one was checking against this fingerprint. So nobody was aware that this is not the binary that should be used, because even SolarWinds doesn't know that this is a compromised binary. So they have 300,000 customers or whatever, and after this attack against their CI environment was done, and they rolled out the first update, I think 20,000, 30,000 customers just took this update and installed it in the system inside their infrastructure management software with a huge amount of rights. So after this one, this piece of software was sleeping for around 2 weeks, and then it started loading more code from the internet, from dedicated servers. And with this, the attack was even broader. So they not only opened a door, they opened a lot of different windows, and nobody really knows how many of them. So nobody really got the full impact of this one, maybe until now. And so what does it mean for us is that the quality of an attack is now way better than it was years ago or even months ago, because now the attack group or the hacker group is not attacking the final target. It is going along your supply chain, try to find the weak point, break in and use this one as a multiplicator to come to the final target. And this is a completely new way to attack systems, or it's a new quality, and well, the impact was huge. Okay, what we learned, so what is the lesson learned from this one? So for me as a developer, for me as a manager of a software producing company, or even just as a customer that is using software, well, the main idea was from this hacker group was that they are not attacking the final target, they are attacking someone who's able to multiply everything. So I have just one target, and this target is spreading everything around the world and give me a lot of compromised targets. And yeah, so it means check even the weakest part in your whole supply chain, because this is one point that is critical. Be aware of that every binary that's coming in can be compromised for sure, but even if you're producing it, make sure that you have an eye on everything that will be produced. Scan your own CI environment. For example, have you ever checked your own Jenkins against known vulnerabilities, or whatever it's part of your CI pipeline? Do it, and you will see there are a lot of things you could improve. But the main tool, again, this one is scanning binaries, because if SolarWinds would have been checked all binaries they're producing by themselves, or everything they're using during the production of their own binaries, they would be able to identify there is something different to what we are expecting. And they haven't done it. And not only this one, there are a few other things, but this was one of the things that would be able to help. And the main thing what we learn out of it is scan all binaries. Definitely, if you're consuming it, if you're creating binaries, every dependency, everything, scanning binaries is one of the main weapons against known vulnerabilities. There is one big question, so if you're impacted, how fast you can recover, and why JFrog customers can recover quite fast. So the first thing is you need to identify if you're impacted, and this means you need the knowledge about all binaries in your whole tech stack, and you need the information that there is a vulnerability, and then you have to identify, if you have this compromised binary, what is the place where it's used. So to identify if you're infected, you can use Xray database to identify the binary itself. And the next thing is you can use the query API to isolate this binary in a way that you can see what is the full impact graph. So this binary is used in what are the aggregating or component artifacts. And this is one thing that's very important, because if you have to do it manually, then this is a huge amount of work to identify and to check if you have this binary, what is a place where it's used, and so on and so on. And with this query language from Artifactory, it's in SQL style query language. You can identify quite easily if you have this binary used somewhere, what is a place where you're using it, and at the same time, the question is how to recover from this. You identified that you have this compromised binary, you identified all the components that are using this compromised binary, and now the next thing is how to get rid of it. And for this you need the possibility to ask your system with a SQL style API, with a query language, what are the infected components, and with the same SQL style API you must be able to isolate or delete exactly this binary and make sure that this will never load it again. So what we can do with Artifactory, and this is more or less a very unique point on the market, is that we are not only identifying with this query language what is impacted and the full impact graph based on this one. On the other side, we can just delete these binaries exactly with this query API as well. And the next thing is we can partially black out this repository, so to make sure that this binary is never loaded again. And with Xray, you can say, for example, stuff like break a build, start a webhook, or even if someone is requesting a binary and I have something in my vulnerability database exactly about this binary, not even download it. So blocks the download, that's not even in our caches. And then if you identify it and remove this binary, what you must do is just using the next version that is without this vulnerability and install everything from scratch. And if you have a good CI pipeline, then this is just an easy thing. So that's just perfect. I love this time of the year because so winter is going and spring is just knocking at the door. And yeah, in the middle of the day you can already just run around with a t-shirt, and well, I love it. And slowly everything will be really, really green in the forest again. Okay, the next thing I want to highlight is, or the next thing I want to explain is the lifetime of a vulnerability. This has different steps and why this is important. So vulnerability has different phases, from there is a vulnerability created until the vulnerability is fixed, and this fix is running in production. So the main question is, what are the different phases? The second question is, what part of this lifetime I can minimize. Say what is a part where I can influence the way how it's done, it's affecting me, and so on. So what is a quick win or the low-hanging fruit at this part from the whole lifetime of the vulnerability, and what phase is the most important for me? So first step, vulnerability is born. So it could be accidentally, it could be because someone wants to create a vulnerability. So we have different ways how a vulnerability is created, but there is this point, vulnerability is there. And then it will take some time until this vulnerability is found. And do we have any possibility to influence this time? So the time between vulnerability there and active until vulnerability is found? No, not really. So if I'm a security researcher, yes, I can influence it in a way that I'm spending more effort there. But for us, regularly or normally, it's no way to influence this one if I'm not paying someone or investing in research and so on and so on. But if this vulnerability is now found, what will happen, and who is involved in this party? The next step after this vulnerability is found from whoever is until this information is public. That's the next phase. And now we have to decide, or we have to look at the point, who is the person that found it. So if it is a bad one, he will just use this information for its own needs, or he will say sell it somewhere, this information in the darknet, whatever, so that this information is hidden as long as possible. That's the main thing. So he will earn some money with this, he will use it for his own stuff, and the main thing he wants to achieve is this vulnerability is not public available, or this information about it. The other thing is we have a good one. So a good one that found this vulnerability, and now we have different paths. So well, if you are a security researcher, your main thing is, or the currency you're paid with, is money or reputation. And it means you want to have this vulnerability rated as high as possible, so that it's a very dramatic situation. If a company is finding it, well, they are definitely, pushing it down, so they just want to announce it, there is something, or even they don't want this information public at all. So if someone is finding this vulnerability and he is pushing it to a place, what are the places he can go through? He can go through the public and give this information to public databases for free. few people are doing it, not everybody, because this information is money. The next thing is he can go to the company, to the project or whatever that is infected, and give the information to them. Some companies are paying for this, and this is not an non-critical thing, because some companies, they are buying this information, fixing it, and they are not making it public. On the other side, again, he is more or less the way of distributing this information, or the people that found something going to this vulnerability databases, as commercial ones, and selling this information. And now we have a challenge, because who is really the final audience, or who will get this information, and this is not clear. Okay, all previous steps, we can't really influence in terms of duration. That means from vulnerability is created until it's found, from found until this information is public. We have no way to influence if this information is public through the vendor, through vulnerability databases, free ones, commercial ones. We have no influence here. But now this information is somehow consumable. What can we do? If you're just looking at this point that this information is consumable via this vulnerability databases, and it's not hidden by a vendor, then we have to look at the value of this vulnerability. So the value of this vulnerability is the amount of money that the researcher or the person that found it will get for it. Some people will give it for free, but a lot of people just want to earn money with this. It's a huge market. So who is a winner in buying it? Well, the person that is paying the most money. So this means that sometimes you have a vulnerability database A or B that's just paying more money, and then a vulnerability is on A or B or whatever. So we have no influence who is buying it, and we don't know who's buying the most. We just know whatever decision we take to choose vendor A or B or C, it will be the wrong one, because we will never have the full amount of known vulnerabilities. The other thing is we have to go with the approach to build supersets, and this is exactly what JFrog is doing with Xray. So we're consuming all these different vendors, free ones, commercial ones, own research, and so on. And we are merging all this information. First of all, we are merging so that you don't have duplicates. And second, we have a superset instead of choosing just one provider. This is good because we want to have all, not just a part of it. And the next thing is we are preparing it in a way that you can consume it with other machines. For example, to break a build, to send a mail, to start a webhook. And this is exactly the task Xray is doing. So in combination, Artifactory is grabbing all binaries, or they are all binaries, and Xray can scan has this update of this vulnerability database as soon as we are merging this data. And so what we learn out of it, we can influence the time until we have this information in a way that we can consume it. We can have that information raw, but then we have to prepare it for our toolings, or we can buy it somehow. Whatever, if I like it or don't like it, it doesn't matter, but money is a winner here. So if you're investing some money, you will have this information mostly faster, already prepared for the consumption, and you will have a superset instead of just a subset of given by the vendor you're selecting. So this is one of the approaches, and now it's time for you to act, because now you can consume this information. We saw that this information is now consumable, so now it's in your hands to do all the things to make it fast. What you need is you need to push this fix as fast as possible into production, and for this you need a CI environment that is fully automated and fast. And you have to clean up all your processes so that this push to production is not limited by human interaction, by some dates, times, whatever, because this is exactly the time that the knowledge about this vulnerability is available everywhere. People are actively using this vulnerability to attack your systems. You have this information and you can fix it, so it's really up to you. If you start with DevSecOps, this is exactly the point where you should focus on first. automating your whole production, making this one fast. And if Xray is giving you this information, this must be done completely automated as much as possible and as fast as possible. Okay, if you want to focus on this time from the vulnerability information is consumable up to its running in production, you need a good DevOps or DevSecOps structure. So first of all, what we learn from the transition from DevOps to DevOps, and what we will learn or how we can transform this one for the learning to integrate security in DevOps. So just a few words to the history, so that we see what we learned and what we can use now for the next transition. Is we had a long time ago this dev team and ops team, and they both have their special area inside the company, so they have their own operations, their own processes and all this stuff. And well, it was always a pain. So the developer was coding some stuff, pushing it to the ops team, and the ops team then was working on it, somehow configuring and doing some tests and then running in production. So sometimes you not even know what the other part was doing. And we had some situation where we learned quite fast what is a good and effective process. For example, in this old dev and ops world, for example, I had a few challenges as a developer a long time ago. It was, first of all, I was limited in terms of if I'm coding a database connection, then I used internal or during the development time name memory database, because on production they used a big commercial one, and this was just not available, or it was not even possible to run it on my desktop. So I coded against this JDBC connection, for example, and then after I've done all this stuff, everything was tested on my side, it was great, it was working and perfect. I pushed it to production, and production then tested it. The first tests were running okay, and then in production a few days later, or maybe an hour later, they had a big bug and the whole thing was crashing. So what happened? First of all, they generated summary, so with the log files, and try to identify what was the customer, the data and all this stuff, and send it to me. I tried to identify how to fix this bug. I've done my best, changed a few things, pushed back to them, and they just tried it again. The challenge here was that this process was slow, because I had no chance to debug on the system or on some equivalent system. A few things just changed, because now it's even on a laptop possible to use the same database management system or whatever. So I can run it just in Docker and can work against, or I can code against this exactly the same API and implementation. So this is cool. But what we learned here is during this bug fix phase, so the CEO was looking at it because a customer was crying, there was some pain, it's not working, no money was earned. So in the middle of the night, the developer and the ops man, they went together to this challenge. So he coded something, pushed it, the ops man immediately put it to production, gave some feedback, both together looked at the screen and tried to debug. And at some point, for example, in my case, it was in a way that during this hotfix phase, I got the permission to upload a binary and restart a service and check the log files. And this was the first state of DevOps, because I had some privileges to do some stuff. What we learned there is we have the special knowledge about ops, we have the special knowledge about dev. So if I'm a dev, I'm definitely not a specialist in ops, but I can learn as much as possible so that I can do all the necessary stuff to push something to production, or to analyze it, or to reconfigure it. So I know enough to work together, closely together, but I don't need to be an expert in everything. And now we're doing the same stuff with security. And now we want to integrate security inside this DevOps cycle. So what should we do and how should we do it? So first of all, if you're looking at this DevOps description, you will see that DevOps is defined in different steps, from developing, testing, and so on. And there is no dedicated security step, and this is right. Security is not a step inside your production line. Security is something like quality. It must be part of every single step. On the other side, what we learn from Dev and Ops is that if you're a developer, you're not an Ops expert. And the same is now with security. So we are not all security experts, but we know enough to do our part of the work. And this is something that's important. So everybody in this production line must be aware of these security items or topics or possibilities so that they can use their tools and they're able to decide, analyze, and work against known vulnerabilities and compliance issues exactly inside their phase where they are working. So, and this is the first thing. So everybody in the team must be aware of the security. Everybody must be aware of the possibilities he is able to do. And then, if you're doing it in every stage, you are going to DevSecOps. And this is a cool thing. But the next thing is, you can do so many things in security. So what would be the low-hanging fruit? So what is the main target you should focus first so that you can start learning about the security process or to integrate security. And this is the next thing I want to highlight. Say, what are the low-hanging fruits of security? So, talking about security and the low-hanging fruits or the quick wins for the DevSecOps implementation or the security implementation inside your DevOps is that we should focus on two terms. One is time to market and the other one is make or buy. So what I mean with time to market is we should focus on how to optimize a whole production line so that we can shift changes as fast as possible to production. What is normally known as time to market in terms of there is a use case and it must be shifted to production so that consumer can use it and you can earn money with this, is the same with vulnerabilities or known vulnerabilities. So if you are detecting a vulnerability, it is a change. It's like a new use case or whatever, and this must run in production as fast as possible. So optimize your CI pipeline. The other thing is make or buy. Make or buy is normally if you have something to that you need. For example, your core business is A, but you need some parts of B. Then should you learn this part of B, or should you buy someone who's able to do it for you and implement this part of B inside A? So we as a developer, we are doing exactly the same. So should I write it by myself or should I add a dependency? And mostly, and this is one of the really interesting things, is that we are buying. So we're adding way more dependencies compared to the amount of lines we are writing by ourselves. So if you are looking now at this difference between how much we are doing by ourselves and how much we added in terms of, or with a normal. Okay, if we are looking at the value of what we are doing by ourselves and what we are adding as a dependency, we will find out that the make is mostly way less to buy adding a dependency. And just as an idea, so during the time we're coding, we are writing a few lines of code, adding a bunch of libraries as a dependency. So in there, buy is bigger than make. But on all other layers, like an operating system, we are just adding a few configurations and all the rest, everything else is a dependency. It is a buy. And this over all layers, Docker, the Docker file is just starting with from. This is a dependency. Same with Kubernetes, Helm charts, all this stuff. So over the whole tech layer we have, mostly the buy is way over 90% of the whole tech stack. And just a few percentage is what you are doing by yourself. And this means if you want to start and be effective in the beginning, you should focus. No, not should. You must focus on scanning dependencies because this is the biggest and most dominant part in your whole tech stack. Okay, with the security part or with DevSecOps, most people are just thinking about known vulnerabilities, but we have two things we should cover. Talking about dependencies means we have, first of all, the known vulnerabilities, and the second thing is we have to deal with compliance issues because every dependency is running under a license, even if there is explicit no license, and we have to cover this one. So, but for both you have different initial efforts and recurrent efforts. So the initial effort for scanning against compliance is that you need someone who's able to decide what's the right license you can use in what part of your production line. And there's nothing worse than GPL at the right place in your project. This can just destroy your whole business case. On the other side, with vulnerability, you don't have this initial work. There's no lawyer needed that have to decide this one. So there, it's mostly that you just taking the machine is scanning all vulnerabilities or all binaries against vulnerabilities, and you will get your first report. But if you have your report, then the human has to decide what should be done. So with vulnerabilities, you don't have an initial effort, but you have a recurrent effort, because with every report, with every known vulnerability you get, you have to decide how to replace the version and so on. With compliance issues, you have an initial high amount of work initially, but mostly the license is not changing over the lifetime of dependency. Sometimes it is. There's just, for example, this movement from this EE stuff, Java EE stuff, to the Eclipse Foundation. There was, for example, a change in the license. So it makes sense that you're checking it, but if you will find a compliance issue, then it's not enough that you're just changing the version number. You need to replace it with a semantic equal implementation, and this is a big beast sometimes. So vulnerabilities is mostly different compositions of versions. Compliance issues means change with a semantic equal implementation. There's one difference between compliance issues and vulnerabilities in terms of the complexity. So if you are talking about compliance issues, then there's one dependency with a wrong license, and then you have to replace it. That's it, nothing else. So you have to find the semantic equal functionality somehow with a different license. On the other side, with vulnerabilities, we have the challenge that vulnerability itself could be with a low CVSS score, but you can combine different vulnerabilities to different attack vectors. So the composition of all vulnerabilities, so the whole amount of different attack vectors, this is a critical thing you should have in mind, or you need to analyze. And this means you need something that is not scanning only just one technology or one layer. You need something that is able to give you the full impact graph. So if you don't know what vulnerabilities in all different layers you have, you're not able to create the full impact graph, and then it's nearly impossible to calculate what is the risk. By the way, if you want to know what the CVSS is, check out my YouTube channel. I have a dedicated talk there and explaining what is a CVSS score, what is the difference between versions, and what are the core components, and how to use CVSS scores for you inside your production line. What a good safety build against compliance issues and vulnerabilities. So let's have a look at the compliance issues. So you need to replace this implementation with a semantic equal one. So what the best coverage here is, or what the best safety build, it's a very good strong test coverage, because then you can replace it, and with the test coverage you can immediately identify if this is good enough so that you can go with this replacement. With the vulnerabilities, it's more or less the same. So a vulnerability means that you have to change a version, then you have a new version composition of the same dependencies. And again, test coverage is your safety belt, because with this you can immediately identify if the behavior of this program is still the same. But you need a good test coverage. A good test coverage is not only line coverage. So from my point of view, you need something stronger like mutation test coverage. If you want to know a little bit more about mutation test coverage, check out my YouTube channel. I have a dedicated talk about the mechanics and the background and how to use mutation testing. But in general, whatever test coverage you take or choose, make sure that you have a very strong and a very good test coverage. So in general, the TDD approach is working hand in hand, not only for the quality, but exactly with security as well. So TDD, quality, security, everything is going exactly in the same direction. Now, what is the best place to scan for all this? We learned that we have to focus on dependencies. We learned that we have to scan against compliance issues and vulnerabilities, but there is one logical place that is a perfect place where you can start scanning, and this is Artifactory. So inside your binary repositories, you have from all package managers the binary there for the whole tech layer, and then you can scan with Xray, and this will give you exactly what I mentioned before. You need the full impact graph over all dependencies. And this means you need one logical point where all dependencies are going through, and this is Artifactory because it's understanding all package managers for all different technology layers. So here, Artifactory with Xray is exactly the point where you should start looking into your tech stack because you have the full impact graph immediately. Okay, there's one thing that is leading to more complex security scenarios, and this is behavior of polyglot systems. So why I'm talking about polyglot systems and what is a polyglot system? So polyglot systems mean that you have different technologies mixed together, and why we're doing it. So for example, if we are mixing technology, then it's mostly to hide complexity or increase the convenience level. Increasing the convenience level is good because your developers are happy, your fast in production is more easily possible to construct complex use cases. And with more complex use cases, we need this hidden technologies or this hiding and this making more convenient. But on the other side, just as an example, so in this microservice environment, for example, it is in a way that every microservice can now written in different programming languages. This isolation is good because then you can freely decide what is the best technology for each microservice. But on the other side, it is a risk because in a monolith, you have one tech layer and everybody is aware of this tech layer and everybody has a knowledge about this tech layer inside your team. With this microservice, if you're now splitting up all these environments with different technologies, your senior developer in Java is definitely not a senior developer in Go. Maybe Go is the best implementation language for this dedicated microservice. But make it sense? Well, a developer will like it to learn a new language and play around with new technologies. But on the other side, it's a risk. But sometimes it's really worth to do it. For example, switching to a different language because it's solving a lot of challenges you have with your old tech stack. So I don't want to say it's good or bad. I just want to highlight that you have different technologies and you have to work with them because everything has its own life cycle. But sometimes it's even more tricky to identify these polyglot environments. Looking just at one microservice, for example, this microservice is just a web UI. Web UI means you have some front-end technologies like HTML5, JavaScript, CSS, whatever. And then your developer team just don't like it. They are server-side developer. They are trained in Java. They are not familiar with all this web stuff. So what could happen is that, for example, they decide to go with Vardin. Vardin is an open source framework. It will give you a Java server-side backend in Java. And on the other side, it will give you the possibility to write with this Java server-side web component-based graphical user interface, web interface. So this is good, but now you have to deal with Java lifecycle, with a JavaScript lifecycle, with a dependency tree in both languages. Sometimes it is in a way that even the developer that's coding this stuff is not aware of the whole text layer. And this means you need technology that is completely scanning everything, going over all text layers and making sure that you will get the information about the whole dependency tree, not only from the visible technology, but really from the whole impact graph. And this is on the one side convenience with polyglot systems. On the other side, you must be aware of all these different technologies and must make sure that you scan everything and have the knowledge, even if you're not aware of that. If you're reading about this DevSecOps topic, then you will see that most people are mentioning that you should start scanning inside your CI environment. This is true, so you must scan inside your CI environment everything that's going in and out. But on the other side, is this the first place you should start with scanning? Definitely no. Why? So there is one term called shift left. Shift left means that you start as early as possible with all these tasks you need to do. And scanning for dependencies is definitely not only possible inside your CI environment. It's possible, for example, inside your IDE. What you're doing as a developer, inside an IDE, you start coding stuff and then you're adding dependencies. Based on your dependency management system, you're adding a config file or JSON file or whatever, but you're adding a dependency. The IDE is aware of this, and then it would be perfect if the IDE would say to you immediately, wait, for this dependency and version you're adding right now, we have this license issues and we have this vulnerabilities. And this is possible, and it's called the IDE plugin from JFrog. So if you have an Artifactory and Xray instance, then you can connect with your IDE plugin through this Xray instance, and if you're adding a dependency, then this plugin knows immediately this is a dependency. It knows all transitive dependencies or all dependencies that is coming indirectly with this dependency, and will use this information to ask the Xray database, what do you know about these dependencies? And you will see it immediately. So inside your IDE is a very good point to start, because it's, if you're adding a dependency and know there is something, you can change it immediately. You don't need to wait until you commit the first thing, push it to the CI environment, and then it's complaining later. So you're burning less money if you're shifting left with your security topics right inside your IDE. If you want to try it out, we have a free tier. I will give you the URL here somewhere, and then you can try it even with a free tier. Then use Artifactory, take the Xray instance, connect through it, and how this is done inside your IDE, I will show you now. Okay, now we have a short view to the Xray IDE plugin. I just added in my Pullman dependency, so this is a Vaadin version. It's a little bit older one, so that we can guarantee see some compliance issues. So what you will have in the IDE plugin here some kind of window. I'm using IntelliJ, so it could look a little bit different on Eclipse or whatever. Then you will see the dependency we added here already. Here this 4120, 4120, and then you have the whole dependency tree, and you see there is a security issue with Jackson data binding. What you get is ranking, if it is a high, medium, or low security risk. You will see the license information, what type, version, and so on. The good thing is you can see here all detailed information. For example, if there is already a fixed version available, and what tiny summary of the issue itself. One cool thing is, if you are somewhere, then you can just go here and say show in project descriptor. Then you're jumping here back to this one. And the good thing is, if you decide to exclude, you can just go here and say exclude dependency. What you will get is dependency exclusion. That's it. The only thing I want to show you is how to install it. So in IntelliJ it's quite easy. You're going to the plugin, you're searching for JFrog plugin, updating it, or just installing it. In IntelliJ you have to do a restart. In Eclipse could be different. And then the only thing you have to do is you're going to the settings of this Xray plugin, adding your coordinates, and then you can just connect your IntelliJ to the Xray installation. That's it. Have fun. We now know that we can use Xray functionality right inside the IDE, and this is perfect because it's the first time we can deal against known vulnerabilities or act against known vulnerabilities. But inside Xray we have different other ways to get to this information. One thing is a vulnerability report inside the web UI of Xray. So go to the vulnerability report and create them, because what you will get is an view on the repositories right now. It's an ad hoc report that will give you a list of all known vulnerabilities at this time you're creating this report. It's just selecting the repository and generating this report. And if you generated this report, it will take some time depending on the amount of binaries inside your repository. You will get this report and you can extract it or can export it in different versions, like as PDF, as a text file, and so on. So you can use this as a machine input as well. The other thing is everything I mentioned here, the whole functionality is available via the REST API as well, and via the command line interface we have. So with the REST API, you are able to do exactly the same queries, and you will get the result, and then you can use it for third-party components. Means if you have, for example, compliance toolings, you can just ask for known vulnerabilities. Then you can feed this information in your auditing system or reporting system, whatever you're using. And this is just a question what is inside the repositories right now. If you want to have a recurrent scan, then we have to go to watches. If you want to implement a constant scan of everything that's going in and out of Artifactory, then you need the construction of a watch. A watch is based on policies and rules, and this I will explain now before I'm explaining watches. Policies and rules are the definition what should happen, but in a stateless way and without any technology. Means policy is a composite of rules, and a rule is just a stateless definition what should happen if you are identifying something within CVSS score from A to B. You can use the CVSS groups, or you can just use dedicated CVSS numbers. If you want to know more about the behavior and the structure of CVSS, check out my YouTube channel. I have a dedicated talk about CVSS, what are the components, how it's created and all this stuff. So just as a heads up. So if you have now this detection, so something is detected, then you can describe what you want to have. You can send an email, break and build, start a webhook, and so on. And the really cool thing is that you can define that you want to start a webhook. And starting a webhook, and in combination with the REST API we offer, means that you can now build fully automated processes around Xray, and Xray fits perfectly in your existing infrastructure if you have third-party components that must be triggered, that must consume this information, and so on. So all these rules then coming into a composite called policy, and policy is just a logical holder of different rules. And the last step is watches. Watches are consuming policies on one side, so the composition of different rules, and on the other side it's connecting to the technology, to the repositories itself. So what you're doing here is that you're selecting the repositories you want to scan continuously, and then adding some policies so that you know what you should do. So how you can structure this one, and at what time this watch will be recreated. The first of all, how to structure this one. If you have these policies and rules, you can build your compliance documentation or your internal documentation that describes what should happen at what CVSS score. You can map directly step by step to policies. These policies are grouped by chapters, or in the same way like the chapters in your document. And then the watches is more or less the connection to the technology. The next thing is at what time this will be triggered. Every time the repository content is changed, this watch will do exactly the same stuff again. Every time the vulnerability databases will be updated from our side, or you're updating by yourself if you're on-prem, then the whole construction will rerun, so the whole watch will be recreated. So every time you're requesting it, the content of the repository that is scanned is changed, all the update of the vulnerability database is detected, and then everything will be triggered. And yeah, well, that's watches. So we have now IDE plugin, we have the vulnerability reports, and we have watches. Okay, time for the conclusion. So what we saw today was, first of all, a little bit about the SolarWinds hack, what happened and how you can prevent all this stuff in your environment with scanning all dependencies. The next thing was that we had a look at the lifetime of a vulnerability from it's created until it's running in production, and we learned that the first step, or the first thing we can influence as much as possible, or in the best way, is the time until the information is consumable up to its running in production. And to get this information as fast as possible, make sure that you have a superset of vulnerability databases so that you're not missing any vulnerability. After this, we saw a bit about what is the best practice to start with security inside your DevOps process, and the main key takeaway here is that security is something that is in every step. It's like quality. Everybody in your team must be aware of the security topics, but everybody should focus on his part of securities, because not everybody is a security expert. On the other side, make it as easy as possible for everyone to consume or to deal or to do this work in terms of security. And for a developer, for example, shift it left as much as possible to provide this information inside an IDE with the IDE plugin from JFrog, because this is directly connected to Xray, and you can try it. You can try it for free with our free tier. I will give you the URL here somewhere, and then just try it. If you want to have a hands-on on this, just register for the next workshop. So I'm giving these workshops mostly 1 or 2 weeks after a webinar, so feel free, register for free, send your tech guys, or just go by yourself and try it out so that you have the feeling definitely by yourself. So my day is done. I'm still in the forest, as you can see, but it's time to leave soonish, so it will be dark in, well, let's say 2 hours. So it's time to pack my stuff, leave the forest, and I wish you a good day, whatever time you're seeing it, in the morning or in the night or whatever. And well, if you like this style, please check out my YouTube channel. I have a lot of other outdoor style IT related videos, and I would really appreciate to see you in one of my next webinars. So register for the next webinar, register for the workshop. Stay safe and see you.